Hello friends and welcome a lecture on kinematics of fluids part 1. So in this lecture we are going to cover what is meant by kinematics, then types of flows, then some graphical methods of the kinematic analysis. So fluid kinematics is one of the important branch of fluid mechanics. So in fluid kinematics, we are going to analyze the flow for its velocity and acceleration. But in fluid kinematics, we are not going to consider any kind of forces acting on the fluid flow. So only we are going to consider the motion of the fluid particles. So that we can say that it is generally a continuous function in space and time. So to describe the methods of fluid flow, there are two types of methods. One is Lagrangian method and one is Eulerian method, or we can also pronounce as a Eulerian method. So these two methods are described by the fluid particle motion. So in this method, we are going to analyze the fluid flow and we are going to know what are the changes in terms of velocity and acceleration of the fluid flow. So first method is Lagrangian method. The scientist Lagrangian have described this method, hence the name is given as Lagrangian method. So in Lagrangian method, a single fluid particle is to be taken or it's considered and its motion is analyzed. But in case of the Eulerian method, the one at a one point is selected and at a one point how the fluid flow is full flowing, that analysis is done. So first method is there, Lagrangian method. So this Lagrangian method define mass, velocity, acceleration, pressure, all the properties of fluid in as a function of time. And we are going to consider one single fluid particle and we are going to track the motion. So for example, if the birds are migrating from one place to another place, so their analysis, so we have to track the motion of a single bird. That is, and we have to calculate what's its velocity, what's its speed, what's acceleration change, etc. So one bird, how it is migrating from one place to another place. So that is nothing but the Lagrangian method. So another method is there, Eulerian method. So in this method, it describes the fluid flow. Also, here also we can say that here velocity, acceleration, pressure, temperature are the properties of not only time, but they are also properties of space. But in the Lagrangian method, they are only properties, they are properties, functions of only time. Here, time and pressure. So if a crowd of birds are flowing, then counts of birds passing through one particular point or through a one space, how much birds group is flowing, that is nothing but Eulerian method. So at a once here in Lagrangian method, the analyzer or that observer who is observing the flow have to move with the particle. But in case of Eulerian method, it have to be need to be steady at a one particular point and he has to study or analyze the fluid flow. Then in the fluid flow motion, as we are going to describe only the velocity and acceleration in kinematics, the important part is there, the types of fluid flow according to the change in velocity or according to the type of velocity. So there are many types of fluid flow. First type is there, or we can say I will here you highlights. So first is steady and unsteady flow, then uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flow, one dimensional, two dimensional, and three dimensional flow. Now, one by one, we'll discuss about these types of flows. Steady flows. So, steady flows is that kind of flow where the fluid characteristics like velocity, pressure, density, etc. point do not change with respect to time, or these velocity, temperature, pressure, density remains constant with respect to time. Okay, so this kind of flow is called as steady flow. For example, here if we store, if we take the discharge from a tank whose water level is kept constant. So if water level is kept constant, every time we are getting same discharge, that is called as steady flow. Then unsteady flow, the fluid properties like velocity, pressure, density do changes with respect to time, or they are not remaining constant with respect to time. For example, we are taking the discharge of water through a tank whose level is not maintained constant. So as his head is goes on decreasing, the level is goes on decreasing, or discharge automatically obviously decreases. Then uniform and non-uniform flow. Uniform flow is a function of space, okay, in which the velocity at a given time does not change with respect to space, length, and direction of flow. So for every point in the fluid flow, the velocity is remaining constant. So velocity does not change with respect to space at a given instant of time. Then that type of flow is called as uniform flow. For example, the flow of fluid in a uniform diameter pipe is example of uniform flow. Then non-uniform flow, in which again opposite to uniform flow, in which the fluid velocity changes with respect to space at a given time. So here non-uniform tapered pipe is there. Here this pipe is tapered pipe. So here this is going to be the example of non-uniform flow. So flow of water or flow of fluid in a non-uniform pipe is example of non-uniform flow. Then another important is laminar flow and turbulent flow. So laminar flow is the flow in which the fluid particles moves in streamlined manner or moves in parallel to each other, and they are moving there. These particular fluid particles layers will not cross with each other. These are parallel to each other and it will not cross each other, and the velocity of the flow, laminar flow, is always very less, and therefore laminar flow occurs at very low velocity. Then turbulent flow, in this fluid motion, in this fluid type of flow, the fluid particles are moves randomly and they are not in streamlined manner. The fluid particles mixed with each other and they flow in zigzag way. And there is efficient mixing, is the mixing of the fluid flow is there, and the velocity is much more for this particular flow, and fluid particle are get mixed. So generally, whatever the flow of water is there through a municipal corporation pipeline is a turbulent, or whatever the fluid is flowing in a pipe for agricultural purposes, that is also having turbulent flow. The turbulent flow occurs at very high velocity, and for this one number is there, it is called as Reynolds number. So Reynolds number is less than 2000 for laminar flow, and Reynolds number is more than 4000 for turbulent flow. Then another type of flow is there, that compressible flow and incompressible flow. So compressible flow is that type of flow in which the density of the fluid flow remains unchanged or varies, in which the density of the fluid particle changes point to point. That type of flow is called as compressible flow. So all the gases, when they are flowing through a pipe, that flow of gases, okay, or air is considered as compressible. While incompressible flow, the density of the fluid flow do not change point to point, or it remains constant with respect to space or at different location. So density of the fluid flow is constant for incompressible flow. So all the liquids and water flowing through a pipe is considered as incompressible flow. Then rotational flow is very good example. Rotational flow means what? The fluid particles while flowing rotates about their own mass centers. That type of flow is called as rotational flow. So in which the fluid particle rotates while flowing, they flow, but at the same time they are rotated about their own mass center. For example, we know the general example that Earth moves around the sun. It is also moving while moving around the sun. It also per day it revolves around its own mass center, and that we can call it as a day period. So like this here, fluid particle, for example, is there whirlpool in a water, or in Marathi we say bahura in water. Okay. Then irrotational flow, the fluid particle while flowing along a streamline do not rotate about their own mass centers. For example, general flow. For example, flow a drain hole, whatever the wash basin is there and drain hole. That flow, when the water is drained in vertical direction, the vertical downward direction, it is flowing only in direct downward direction. It will not move about its own mass center. So that is called as irrotational flow. Then one dimensional flow, two dimensional flow, and three dimensional flow. One dimensional flow means the flow in which velocity is always function of space and time. Here, the one dimensional flow is that type of flow in which the velocity is function of time and only one space coordinate. That type of flow is called as one dimensional flow. For example, velocity flow of a fluid in a pipe, horizontal pipe. So that we consider only along its length. Then two-dimensional flow is the type of flow in which velocity is function of time always and two space coordinates. That is called as two-dimensional flow. In that case, the flow of a river considered for its length and let us consider its width also. Length, how much it is going, and at the same time, how much width that particular water is covering. That type of flow is called as two-dimensional flow. And obviously, last one is three-dimensional flow, in which velocity is function of time and three space coordinates. For example, the flow of river considered for its travel length, width, and depth. So that is called as three-dimensional flow. Then we have to graphically we have to visualize the flow. To analyze the flow, first our method was a graphical method. So visualization. So flow visualization is the visual examinations of flow field features. So flow for that numerous methods are there that we have to plot the streamlines, path lines, and streak lines of the flow. So one of the important property, one of the important concept in flow visualization is streamline. So what is streamline? The streamline is a curve that is everywhere tangent to instantaneous local velocity vector. So the velocity vector, if you draw for a streamline, and that velocity vector, we know vector always gives direction and magnitude. So these streamlines, tangential component to streamline, always give the velocity component. So tangential component of streamline always gives velocity component. So by plotting streamlines and by plotting tangential components to streamline, we can get the velocity vector, that is direction and magnitude of the velocity. So this streamline, so here it is one of the streamline is there. So here one this is going to be streamline is there, and the tangential component here it is giving the velocity vector. Velocity vector means here it gives the velocity vector v bar. So this is going to be, so here it is going to be streamline is there. So this is going to be the streamline. So streamline for steady flow, it is fixed in space. But for unsteady flow, streamline moves means different. The streamlines having different fluid pattern at different point. Then path line is there. Then when a fluid is flowing from one place to another place, the fluid particles move from one place to another. So in that case, here they are traveling. The path line is a actual path traveled by the fluid particle for a period of time. So when the path, this path line may be straight, may be zigzag, and this path line may intersect with each other. Okay. So this path line is nothing but path traced by the fluid particles over a period of motion. Then path line is we have considered. So this is going to be the path line zigzag way. It may be zigzag or one path line may intersect with another path line. Then another concept is their streak line. Streak line is nothing but like a streamline only, but to study the purpose in the experimentation, we have to inject some colorful solution or dye in the fluid flow and we have to analyze the fluid flow. Then that kind of streamlines or flow lines we are getting when for the purpose when we inject the dye or colorful solution in the fluid, then that type of flow lines are called as streak lines. And they are passed when experimentation they pass through a one fixed point. So that is called as streak lines. For example, if you take the example of a stick, okay, scented stick we can take, and if we here ignite that stick, then definitely the gas flows in the atmosphere having their flow lines are observed in the atmosphere, and they are coming out from one fixed point that is called as streak lines. So, and a trace means tracer injected continuously into flow. So that fixed points are there. So they streamlines, streak lines, path lines are same for steady flow. These three lines are same for steady flow, but for unsteady flow, the streamlines, path lines, and streak lines are not identical. So this way, in this chapter, we have covered the flow visualization methods, then flow analysis methods, and types of flow, and also we have gone through what is meant by kinematics. Thank you very much for listening this. So next video on the fluid kinematics part 2, we will cover the how to calculate velocity and acceleration of the fluid flow, then continuity equation or some analysis terms required in the fluid kinematics. Thank you very much.